Okay, 3 people. I'm going to start because I'm recording this anyway. So I'd rather you guys get hacks done than watch me. So I'm going to talk about NuPIC, the open source project, not necessarily anything technical at all, except for kind of our plans. I'll talk about sort of the history of the project over the past year since we went open source, where we're at right now in our evolution, and also what we're planning for the future. So I think you guys here all know me. I'm Matt Taylor. So I'm the open source community flag bearer. That's a self-title. But as well as kind of managing things on the mailing lists, kind of emceeing conversations and such. I also do sprint planning. I'm the scrum master for the project, and try and keep everyone on the same vector as far as work goes for contributing to the project. So let's talk first about where we have been. So we open sourced on June 3rd of last year. It's almost been a year now, with almost 90,000 lines of code all at once dumped onto GitHub. When this happened, there was no issue tracking. We had no continuous integration. We had no public unit testing. We did not have a swarming library public, and we only supported Python 2.6 and GCC. We've come a long way since then, but basically it was just one repo, one lump, everything in the same place, C++, Python, encoders, everything all in one spot. So very quickly after June 3rd, on the 21st of the same month, we had our first hackathon in the Numenta offices. It was a 24-hour event. We had 15 to 20 sort of solid people. At the end, it turned out that we turned out 8 demos, about half of which were somewhat significant, but we ran into lots of build problems, which I think turned a lot of people off right away. But I would still say it was a successful event for a project that's been open source for less than a month, and we generated a lot of buzz. And that was fun. We had a few interesting demos come out of that, and those were all recorded, and you can look at them on our blog, numenta.org/blog. We had another hackathon last year in the fall, in November, which had about double the attendees, a little more. That was up in San Francisco. This one we decided to put on some talks, so we had Usability and Jeff talk, and we tried to have a natural language processing focus, so Usability and myself tried to do some hacks on that. Also got a lot of buzz off of this. We do this to engage the community, to get people involved, and as far as that went, it was very successful. We still had a lot of build problems. It was still a pain to get people up and running with NuPIC so they could even do hacks. So we recognized this was a big problem. In January of this year, I started full-time as the community manager, and the first thing I did was take a poll on our mailing list for our community to tell us what the most important thing they thought should be done within the project. And we got a lot of responses. But there were 3 main themes to these responses. The first being transportability. People did not want to be tied to Python or Python 2.6 or any particular programming language at all. They wanted something that could be put up in many different languages, virtual machines, environments, etc. There's also a lot of feedback about usability. People wanted better documentation, code samples, tutorials, and they wanted the build to be easier, which was very obvious feedback for us who realized this. And people also wanted hierarchy. So this was all community feedback, what people wanted out of NuPIC. So we decided we were going to try and focus the community on accomplishing these goals. For the first bit, the transportability, we came up with a plan, which is what we thought everyone wanted, was to extract a core that was transportable in different environments. So we did have a C++ core already, kind of buried within NuPIC, and we wanted to pull that out, provide an API for that C++ library, and language bindings and language clients, so that theoretically anyone in the community could create a language binding for their favorite language and create a client, just like the OPF is a client in Python. So that is still the plan, and we're still working towards that goal. We also have been making a lot of build improvements to address the usability concerns of the community. We've got a CMake build, which is drastically improved from our previous sort of just shell script build, and that was just entirely provided by our open source contributors. So we're really happy about that. That's a big thanks to Marek Odehall and David Ragazzi. We also got out of that better compiler support, so we run builds in both CLang and GCC, and we support Python 2.7. So we have a build matrix that consists of those two compilers, Python 2.6 and 7, and our build process is actually simpler at this point. The installation isn't as hard, doesn't take as many environmental changes, and that was fairly evident yesterday when we had our install-a-thon, and it went very smoothly, as opposed to previous hackathons where it took hours of arduous work. We also have Docker support for virtual machine that's been working out pretty well for people. So where we are at right now, we're at a point, I've been working a lot on usability, creating tutorials that are very sort of beginner friendly. We have the sign tutorial. Subutai provided some swarming examples in his code base that also works against the signs. And we have a new hotgem tutorial. We also have some community provided tutorials like the audio stream example and a spatial pooler example that came from a community member as well, which are also helpful. And I made another screencast on how to contribute to NuPIC using our process for Git, GitHub, and Travis. So this is all trying to work towards addressing concerns about usability for NuPIC. We also have been working on API documentation for core, for example, again with community contributions. We have a contributor recently who has done a bunch of work with Doxygen on the NuPIC core API, really fleshing out the network API, and he's continuing work on that. That's Utensil Song. Thank you for that work. And I put a lot of work into giving our wiki facelift and kind of guiding people from never seeing NuPIC to kind of what resources they need to move to understand the theory, how to install it, how to use it, and then learning about how NuPIC works and contributions. So the state of our C++ Python split is not quite done. We do have 2 repos now. We've got a NuPIC core that is as an independent build and an independent continuous integration process. So it's totally split from the Python NuPIC repository. But we're not quite done yet. We have this 4-step plan, and we've only really executed step 1. We're working on step 2. So we're moving towards creating a release version 1.0 for NuPIC core and NuPIC. But right now, NuPIC core still needs some work. It does build autonomously. It still needs API testing. We want to define that core API, that C++ interface really well, not just with documentations, but with API tests. And then once we have that defined, we can release. You can't release software until you have public interface defined properly, so that's the plan. And so we still need some help and some work on a C++ test suite with proper reporting in XUnit format, so we can do analysis of unit testing coverage over time and all that good stuff you get from enterprise-style software projects. All of this moving towards a release version 1.0. The one other major thing that we're missing in NuPIC core is the sequence memory algorithms, which are still in Python. So that needs to be ported from Python into C++. That's really the major code piece that's missing before we can truly make NuPIC Core totally independent and have all of the spatial pooling, sequence memory, algorithms, and what we currently call temporal pooling. So as we work towards adding some of the things Jeff and Subutai and Chetan have talked about in the future, we're going to be prototyping those things in Python, in the Python client, with the goal to transport them all into C++ once we're done with the prototypes. So the state of contributors at the moment, this is, sorry about the display, but we've got 93 contributors, 94 soon, because I've got a CLA on my desk I haven't processed yet. 28 of you have pushed code into either NuPIC or NuPIC Core. We've got 10 or so consistently active developers, which has been really great. We have 11 committers. 3 of those have been promoted from our community. Due to high activity and lots of interaction with us and suggestions, so that's great. We're really happy about that. And we have a really active mailing list. Total subscribers to all 3 of our mailing lists is almost 800 now. Of course, there's a little crossover between those if you're subscribed to 2 or 3 of them. But for the most part, the general discussion mailing list is almost 500 subscribers, so and lots of messages. If you're subscribed to the discussion list, it's a lot to keep up with sometimes. So this is just a pattern of steady growth over the past year. So this is kind of all the trends I try and track. GitHub followers, GitHub forks, or Twitter and Facebook, social media stuff, and then subscribers and mailing list messages. So we're having a good, healthy, steady growth. We're not looking to grow extremely quickly. That can be kind of hard to maintain. So I am very happy with this. My workload has increased quite a bit over the past 6 months just based on all of the different activity that's been coming from our community. So we're really happy with the NuPIC community growth. Where we're going in the future. So we've been talking about this for a while. Jeff has published his ideas on temporal pooling that he wants to implement. And so we want to try and make this happen as soon as we can. And Jeff and Subutai will be working on this as soon as they have the bandwidth to do so. So we want to try and move towards hierarchy, and getting these new temporal pooling ideas in place and motor ideas in place is going to be moving in the right direction. So again, we're trying to address the community's wants and needs. They want to move towards hierarchy, and that's where we want to go too. I would say like the pie in the sky dream here, and this is partially me speaking, so I can't speak for the entire community, but this is the impression that I get from the community conversations that I monitor all the time, is we want to have some way to easily configure a hierarchy of lots of different CLA regions and make that distributed. So you have the potential to have each region implemented in a different client language, potentially on the cloud somewhere, and some type of standard communication protocol. So you can have all these regions talking to each other, passing SDRs back and forth to each other on the cloud, or however you want to call it. So I think this is a good goal. A lot of people in the community are kind of striving towards this, would love to have this at some point, and this would really be an interesting situation to try and set up. So it's going to take a lot of work, but we're going in that direction as quickly as we can. We also want to have a sort of a global standard for model serialization that is fast. Right now, our model serialization is dependent on Python, so we want to have that ability to serialize models up at a higher level, potentially within the core itself, so that any one of these distributed nodes that's running CLA can serialize its state and pass somewhere else, and they can reinstantiate it and have all of that memory of the data that's been seen transportable into different places. So that's another goal for transportability. Sort of a thing that I want is to have a hosted swarming service someday. Swarming is a very CPU intensive process. It requires you to have a database installed. One of these days I'd love to try and have an initiative to create sort of a software as a service swarming interface, RESTful API, something easy that any one of these clients, you know, Python client, a Go client, a Java client, a Rust client, they don't have to re-implement the entire swarming logic to get the proper model parameters for a data set. They could just be an interface to some hosted service that can run the swarm for them. So that's a dream of mine, hopefully someday we'll have. And Jeff talks about this a lot. Hardware implementations of CLA and HTM would be awesome. Lots of people are interested in running it on GPUs, but even more than that, you know, implementations on silicon. And there's big companies interested in this. There's IBM and there's Seagate, and they want to do this sort of thing, and they're investing research dollars in it. People are working on this right now. Some of them are working closely with us, or they're looking at the CLA, they're running the CLA, running NuPIC, trying to figure out how they can do this in a hardware implementation. So that could be very cool at some point in the future. So last slide is a motivational slide, and it's just, I want to remind you guys that all of this work that we've done has been largely thanks to the community that has helped NuPIC sort of evolve since we have just thrown it to the open source community. We're trying to be as responsive as possible to community feedback and take that into consideration and drive in the direction the community wants to take this project. And I think we've done a pretty good job so far, but we need more contributions. We need more people that are interested in working on OPF, the Python client, expanding its interface, making it simpler, doing your own tutorials, even diving into the algorithms in C++. If you have some expertise and you see somewhere that you could help contribute, I encourage you to email me if you need to ask me how you can contribute. Go to the wiki where it tells you how to contribute. We need your help. So that's it. That's all I got. Thank you.